All right, last but not least here is evaluating the compositions of functions. So we have f of g of x, g of f of x, and f of g of x. And if you don't like this notation, you can see in calculus that we obviously went through that notation. We used this notation, and we did this notation. Okay, so they really represent the same thing. I do sometimes like actually writing this. It is a little bit easier to write it and then not miss some parentheses. But as far as understanding what you're supposed to be doing, obviously the composition like this is going to be the preferred method. So when you write it like this is basically saying just take the g of x function and plug it in to the f of x function, right? So we have f of x, which is 1. All right, so that's going to equal. So we're going to take the g of x function. So really it's going to look like this, plus, and you plug the g of x in for the x, right? So it's really 1 plus g of x. Well, what is g of x? That's this square root, or square root of x minus 1. So therefore, that's going to be 1 plus the square root of x minus 1. And that's it. There's really nothing else we can kind of do with that. For the next one, we're going to take f of x, and we're going to plug it into g of x. So that would kind of look something like this. So we have the g of x function, and then we're going to plug f of x in for the x. Well, now f of x in this case is 1 plus x minus 1, and that just simples to the square root of x. And the last one is f of x, which is basically just plugging f of x into itself. So that'd be 1 plus, instead of g of x, in this case is going to be f of x. Well, f of x again is 1 plus x, so therefore that can simplify into 2 plus x. And there you go, ladies and gentlemen. We are now